This is geotrig lesson 1, day 1. So first part here we're going to talk about is points, lines, and rays. So we have some definitions here that we should fill out. Maybe I'm actually thinking of adding one extra one here, and that is, what's just a line in general? What's a line? Never ending. Good. I like that. Elaborate. Can't. Okay. It's never ending and it goes in both directions. It's straight, right? So if we're talking about a line, it is got two arrows. So I could put points on your line. Would you guys agree with this? That you have things on your line, and then we can say, hey, that's line A, B. So we have line A, B. So lines are straight by definition. So you don't have to say, what is a line? Oh, it's straight. It doesn't curve. A curved line is a curved line, right? Or it's a curve. It's generally not a line. Lines also don't have a thickness, right? It's this idea that it's connecting a bunch of points together, especially when we're graphing lines. It's the point, it's all the solutions to the equation. But we have line AB, and if I want to quickly denote line AB, all I have to do then is take AB and actually draw a little line above its starting and stopping points. Or it doesn't have starting and stopping points. So line AB would be the same as line BA, right? Are they the same? If they go to the same, if they go indefinitely in both directions, it didn't matter if I'm coming from B going towards A or from A going to B. It's the same exact line. Something that's a little bit smaller than a line would be something we would call a line segment. What's a line segment? It's got 2 points. And a starting and a stopping. So a line segment starts and stops. So it's part of a line, right? Yeah. Part of a line. It starts and stops. So now if I have points that are connected, so H, G. Now we have line segment H, G. So if I have H, G, the difference is I just put a line. Are there arrows above that? No. No arrows. Sometimes they will actually still put the endpoints on. So some books will get a little lazy and they don't actually put big heavy circles on the end. And some do. Those are line segments, HG. Different than a line, correct? Not the same. What does it mean to be congruent? Same. For things to be congruent, it means to be the same. It means to be equal in all perspectives, yeah? So we can kind of think of your desks. Some are a little bit different, so they're not exactly congruent. But I would say the two desks, your desk and the person next to you, could be congruent. The tabletops are the same, the desktops. Your seat bottom, the seat backs are the same. They essentially come off the same assembly line. The structure that holds them up, most of them are the same. They're missing the basket. Some of them have a basket. So the ones with baskets are congruent. The ones without baskets are congruent. Right? Pieces that are in the same place, corresponding parts are congruent. Okay? That means those objects are congruent. Same. What's a ray other than a drop of golden sun?
It's got an end in respect
starting point, and then it goes on for ever. So it starts in one spot, goes forever. So how do we run it? Starts at a point and continues forever. That might be okay. So what does it look like? That's a ray. Could I name that ray? Give me 2 letters. C F. Now granted, you know what I did? I had to add a point for F. What does it mean? I'm starting at point C going towards F. Am I stopping at F? No, I'm continuing on. So this is ray CF. Notice that it has an actual ray above ray CF. Kind of makes sense. We're not reinventing any wheels here, right? We're not trying to do something different. We're trying to stay the same. Origin. What does origin mean? Origin would be the start. So the origin of the ray CF is C. Is ray CF the same thing as ray FC? Or ray AB is the same as ray BA if I go all the way back up to these guys? No, because they have a different origin. They start in different spots, right? A ray starts in a place, goes on forever. Lines go both ways and forever. Okay? So the origin is a starting place. If I was actually talking about two-dimensional graphs, which we all know how to do already, that would actually be what point? 0, 0 would be the origin in an xy plane, right? What's collinear mean? Collinear. Maybe it might be easier to think of it the same as, what if I was co-teaching this class with someone? What does that mean? What does it mean to co-teach? Two teachers teaching together, right? So to be collinear, 2 lines,
next to each other.
not necessarily next to each other, but to be linear means to be a line. So there'll be 2 things on the same line. So collinear means to be on same line. Now, I know co means like 2, like a co-teach means teach together. It does not necessarily mean it has to be 2 people. We could have 5 teachers that could be co-teaching this class. That means all 5 of us are teaching the same class together, right? Same time, that type of thing. So to be on the same line. So what does it look like? If I told you A, B, and C are all collinear points, means that here's a line, A or B, C, A. They're all on the same line, right? A, B, and C are all collinear, or B, C, A are collinear, or A, C, B are collinear. But what does that mean? It means that line BC is the same as line CA, which is also the line of CA, AC, BA, AB, CB, BC. No matter what combination of points, right? Whatever way you want, They form a line, and that line is the same as any other line with those 2 points. Right?
Yeah.
I mean, you think about your seats, right? We're sitting in columns or in rows. If you pick the column with the students with you in that line, you're all in the same column. It doesn't matter who's first, who's last, you're in the same column. Or in the same line, if you want. You're all collinear. Make sense? Not too bad. Intersection. What does it mean to have an intersection?
2 lines cross.
2 lines cross. Could be more than 2 lines, right? So we'll say where lines cross. For us right now, because we're talking about lines, I'll use lines. It could be where graphs cross. Slash meet, as in they come together. So we have points of intersection, versus where our lines cross and they meet. Next up, planes, not the aeroplanes. We'll go zoom through the sky. What's a plane? Not us. What is a plane? What's a mathematical plane?
A graph.
A graph is a plane, XY plane, right? I said that earlier. It can be a graph, XY plane. The board, guys, the board's a plane. Your desktop is a plane. The floor, the walls, the ceiling. It's a 2-dimensional surface, right? 2-dimensional surface. 2D surface. It's a 2-dimensional surface. There's no height or depth to it. Actually, if you think about it, it's all relative if we go to a 3rd dimension. Because if you take a look at your piece of paper that you guys are writing on, that can be a plane. But if I took that piece of paper, and I'll use the iPad in my hand for you guys. If I turn it on its side and go like this for everyone, I could probably find an angle for everyone where it looks like a line, doesn't it? So if I just hold it just right, you can't tell how far back it actually goes. But if I give it slight angle, all of a sudden you're like, oh wait, there's actually depth to this object. It's a plane. So it takes a 2-dimensional thing and turns it into a plane. Gives it ability that you have, goes on forever. 2D surface that goes in all directions. So think back to what we just talked about. To be collinear, to be coplanar means on the same plane. So parallel lines are on the same plane. Intersecting lines are on the same plane. Okay? Everything that's written on this board right now is in the same plane. They're all coplanar. Everything that's on this screen right now is coplanar. But what does it mean to have skew lines? Skew lines. Do they meet? No. So skew lines don't intersect. So if they don't intersect, they'll never touch. And they're not parallel. So they cannot be parallel. Because skew lines are lines that are in completely different planes. So they're non-coplanar. I'm going to put that underneath. Non-coplanar. Planar, right? Non-coplanar. Which means they're not in the same line. I'm going to try to draw this 2-dimensionally. So if I had see. I don't know if you guys can kind of see this as a three-dimensional graph. If I drew a line right here, this line, which would be up here, would be skew lines. Now this is very hard for me to demonstrate this on here without actually using my hands. But this line is down here. This line, which is coming out of the board, is up here. So I'm going to use some sticks to show this. Okay, next up, angles. We have 1, 2, 3, 4 different types of angles that we're going to talk about today. The first one is what kind of angle?
Right angle.
It's a right angle because it has a box in it. So that is a right angle because it's not wrong. It's a right angle, and all right angles measure how many degrees?
90.
90 degrees. Now, hey, look at this. Is that a right angle?
No,
It looks like a right angle,
it's not.
but can you guarantee it's a right angle?
No.
All of a sudden I go in here and I do that. Now, it's a right angle. Your figures drawn in your book or on tests, quizzes, or on the board, please do not ever assume something looks, oh, that looks like it's 45, or it looks like it's 90, that it is. You have to be able to be for certain by using deductive or inductive reasoning, we'll talk about that later, that it is 90 or it's not. If you see the box, that's a given. They're telling you that's a 90-degree angle. Then you are certain, go for it. But if I did not draw that box in there, now you can't say it. Now you can. Those types of things. Next one. A lot of students get this one wrong. What kind of angle is that?
180.
It is 180 degrees. I'll agree with that. That's not the name. What's the name of that angle? It's a straight angle. It's a straight angle. Straight angles measure 180 degrees. It is basically just a line. So often that is overlooked when doing our problems that even if I took this angle and I split it up 15 different ways, all of those angles that are in between have to add up to 180 because they are a straight angle when put all together. Third one. What is it?
Acute 45.
It's an acute fuzzy one. Because all cute things are fuzzy. Like puppies and kittens. No, why did I heard someone say it. It's a 45-degree angle. 45-degree angle is an example of an acute angle, but I cannot guarantee that thing is 45 degrees. The only way I can do that is if they put something like 45 degrees. Now I know it's 45. But what happens if that was 44? Then all of your work is wrong. Don't assume. Okay? So that could be 45 degrees. That would be an acute angle because acute angles are angles less than 90 degrees. Next. Next one is an obtuse angle. Obtuse. And if it's obtuse, greater than 90, but less than 180. Right? It has to be bigger than 90, but less than 180. The last three definitions for today. Terminal side, initial side, terminal side, and then tick marks. So we're going to talk about an angle like so. An angle, if you guys could think of this, can start and stop anywhere, right? If I'm thinking about making an angle, it will start off as a line where two rays, where one ray is being lifted up. So we have an initial side, and that would be where it starts. And that will rotate to the terminal side. So it opens, right? Initial side to the terminal side. Initial, start, terminal, stop. Now, angles can be formed anywhere in space. So, I know I'm going to use my hands. You can't see this on the graph. But if I start here, I can rotate down. That's it, forms an angle. Initial, terminal. I can turn it upside down and go up. I can turn it sideways. And anything in between. So, for us, we got to know that there's an initial side where we start an angle, there's a terminal side where it stops. Also, you need to realize that they're going to start to standardize things. Put things into the same position so we all are uniform in our thoughts and processes. So, what they do for standard form is they take the angle and they place it on the XY graph in a way, where the middle of an angle is at the origin. The initial side is on the positive x-axis. And for all angles with a positive angle, will open up counterclockwise. Okay? This is something I forgot to talk about with the last group. If I'm going to talk about angles, I can talk about angle A, B, C. Because angle A, B, C have these 3 points of A, B, and C. They use a less than symbol for angle. Sometimes it's a less than symbol. Sometimes it is a, it looks like a 45 flat on the bottom, but then has the terminal side there. So if you're using the typing on your keyboard, it is a little bit easier to use a less than symbol, and hopefully we'll all understand that that would mean angle. It's not the most proper notation, but I think we all could use that if we had to type something up. Otherwise, you have to go to insert and use a math terminology for a less than for an angle. Is that going to make sense? And the last one is tick marks. Tick marks are very important because if I had two triangles that I wanted to say are the same, they're congruent. If two things are congruent, that means their corresponding sides are also congruent. Their corresponding angles are also congruent because everything is the same. And so I can put a tick mark. This angle and that angle are the same. That's a tick mark. Put two bands, two tick marks on this one to say those two are the same and it's different than the other one. I can do the same thing for sides. Put a single tick mark on there. Those two sides, you know, are the same. They are congruent. The same length, everything. Okay? Those are tick marks. Used to denote sameness. Homework day 1 of lesson 1. So all of this, all of that needs to be written on your slide, plus all the rest. But homework, lesson 1, that's L1, day 1, page 12 of your book, 1, 6, 10, 12, 17, and 18. Now, 17 and 18 are the only problems that deal with definitions of things we talked about today. All the rest of it is prior knowledge information. Number 1 is a complementary and supplementary angle problems are being 5 times an angle. The first initial sentence is the problem of that. The next 2 sentences or 3 tell you what or how to do the problem. Read it. Yes, it's a fairly large problem, but they tell you how to start it. 6, 10, and 12 are exponent rules, order of operation rules, and adding fractions together with x's in the denominator. So they're all review type style questions. Work on them, come back with questions. Otherwise, have a great day.